Part 6, Advanced Topics. Number 30. Use a system of equations to solve the situation below. So we have our three angles and we have one of the side lengths. So we know that all the angles in the triangle equal 180. So we can write that as one of our equations. So we have 4x plus 2x plus 3y equals 180. And if you combine like terms, you get 6x plus 3y equals 180. And then we also have the other equation, x equals y minus 15. So to solve this system, we can use substitution. So wherever you see an x in this equation with the 6, we'll plug in y minus 15 instead. So that'll look like this: 6 parentheses y minus 15 close parentheses plus 3y equals 180. From there, we'll distribute, combine like terms, solve for y. So we have 6y minus 90 plus 3y equals 180. From there, we'll combine like terms. 6y plus 3y is 9y minus 90 equals 180. Add 90 to each expression, both sides. And so you have 9y equals 270. Divide each term by 9. And then you get y equals 30. So we can plug that back into this equation to find x. So we have x equals 30 minus 15. X equals 15. So we have x equals 15 and y equals 30. Now to find our angles, we're going to evaluate. So this will be 30 times 3. That would be 90 degrees. And then we have 2 times 15. That would be 30 degrees. And then our last one, 4 times 15, would be 60 degrees. And their side length would just be 15. And that would be our solution to this situation. Number 31. Use a system of equations to solve the situation below. So we have two vertical angles, and we know that will be equal to each other. So for first equation, we can have 4x plus 10 equals 2y. For our other equation, we can have these two equal 180. So we have 9x plus y plus 2y equals 180. From there we will have everything in standard form, so have the x terms and the y terms on the left side, have the constants on the right. So your first equation would be 4x minus 2y equals negative 10. For your second equation, we have 9x plus 3y equals 180. Let's go ahead and use elimination for this one. Let's eliminate y. To eliminate y, we'll have to multiply the first equation by 3 and then multiply the second equation by 2. And that will give you equation 3. Now, the reason why is because 3 times negative 2 is negative 6, and 3 times 2 is 6. Negative 6y plus 6y is 0y. They eliminate. So we'll go ahead and write that step down here. We have 3 parentheses, our first equation. And then we have our second equation times 2. So from there, we're going to distribute, multiply every single term by the number on the outside, even the constant on the right side. So we have 12x minus 6y equals negative 30, and we have 18x plus 6y equals 360. From there, we'll combine the two equations. So we get 30x, the 6y's are eliminated, equals 330. So divide by 30, divide by 30, you have x equals 11. From there, we'll plug that back in to get y. Let's just plug it into equation 1. So we'll plug in our x for the equation. We have 4 times 11 minus 2y equals negative 10. We have 44 minus 2y equals negative 10. Subtract 44 from each expression, both sides. So now we have negative 2y equals negative 54. Divide each term by negative 2. And we get y equals 27. Using our two found values, we could find the angles. So 2 times 27 would be 54, so this one's 54 degrees. And we'll do this one. So we have 9 times 11, that's 99, plus 27. And we get 126. So that would be the solution to this situation. Number 32, evaluate the determinant. So for this one, all we have to do is we'll find det of this matrix, and we'll say that this matrix is called A. So the determinant of matrix A is going to equal -7 times -2 minus 3 times 1. We evaluate that. So you have 14 minus 3, and that equals 11. And since it does not equal 0, we can say that this is independent. That means no matter what we set these equal to, so like -7x plus 3y equals whatever number you want, if you sub anything you want, they'll always give you one exact answer. It will never have no solution or infinite solutions. Number 33. Give an example of a 2 by 2 matrix for which the determinant is 7. So we want to find some A, B, C, and D such that the determinant of this matrix would be 7. So we could have lots of different things. But what we do know is that A times D minus B times C equals 7. And we could just plug in some numbers. Let's let A equal 1. Let's let D equal 7. Let B equal 3. And let C equal 0. That equals 7. So that works. So your determinant for this could be this matrix right here. The matrix for this determinant could be this. So we'll have A is 1, B is 3, C is 0, and D is 7. And that works. And again, you could have unlimited amount of possibilities for this. See if you could create a different one using different numbers that still equals 7. Number 34, evaluate the determinant. So there's multiple ways you could do this. One way that looks like a lot of you are wanting to do is doing the cross product thing. So we just rewrite the first 2 columns. So after we've done that, we're going to find the products. We'll take the products of all of these three. So let's find those. We get -7 right here. And then this one is -4. And the last one is 49. And then what we want to do next is get the products of the other side. These sides will be negative though. It'll be the opposite sign. So for this one we get -14. And then for the next one we get 0. And for the last one we get 14. Wait, this one right here should be a 0. So now we'll take the difference between the red ones and the blue ones. So we'll write that out. -7 plus 0 plus 49 minus and then our blue part, parentheses, -14 plus 0 plus 14. So we have -35 minus 0, and that's just 35. And we could check this with the Desmos calculator, desmos.com/matrix. Create your matrix exactly how you see it. Press enter. And they will press DET for determinant and A because they called this matrix A. And then it says it equals 35. That's the same thing as what we got. So we checked our answer. Because 35 is not 0, we know it's independent. Has one unique solution. Number 35. Find the product if possible. So the first thing we want to do is find the dimensions of the first matrix. We have 2 rows, 3 columns. This is a 2 by 3 matrix. And then we look at the second matrix. We have 3 by 2. So that's a 3 by 2 matrix. Since the first matrices columns match the second matrices rows, that means we can multiply them. And your product will be the 2 and the 2. So from that we could write like a little template right here. For the matrix, that's a 2 by 2. And I'll let this part be red. This step will be blue. And then let's do a green for this one. And then like an orange for that one. Okay, so from there we want to find each of these 4 elements. So to do that, we want to first multiply the first row by the first column. So that will be -2 times -5 plus 2 times 6 plus 0 times 1. Evaluate that to get 22. So we're done with the red part. So we can put 22 inside this box. That's our first element in the top left-hand corner. Now we want to do, let's go ahead and do the orange one. So, let's do the orange one. So it'll be the second row by the first column. So we'll multiply those together. We get -6 times -5 plus -2 times 6 plus 5 times 1. Evaluate that. And then you get 23. So we'll write 23 in this box. And then we'll do the next box, the blue one. So we'll take the first row times the second column here. So we'll multiply that out. So we have -2 times 5 plus 2 times -4 plus 0 times 7. And we'll evaluate that. Get -18. So we'll put -18 in the box. Now we want to find the last box, the last element, the green one. So to do that, we want to multiply the second row by the second column. We have -6 times 5 plus -2 times -4 plus 5 times 7. And you should get 13. So we'll write 13 in the box. So our answer is this matrix. This is our product. And you can always check this in the Desmos calculator as well. Number 36. Solve for x. Hint. Add the matrix on the right side, then multiply each side by 1/2. So let's go ahead and do what the hint says. So we'll add this matrix to both sides. So that makes these cancel. So then we have 2x equals the matrix -6 plus 2, and then on the second row we have -2 plus negative 6, and then the next row we have negative 13 plus negative 9, and then last row we have negative 20 plus 6. So we'll combine these together to get the matrix negative 4, negative 8, negative 22, and negative 26. To get rid of the coefficient 2, we'll divide by the reciprocal, 1/2. Well, we'll multiply by the reciprocal 1/2. We multiply by a scalar, we do that to all the terms inside the matrix. So the matrix X equals negative 2, negative 4, negative 11, negative 13. Number 37. Sometimes, always, or never. If given matrix A and matrix B, then A times B equals B times A. Justify your answer. This would be sometimes. So let's just say that we had a 2 by 3 matrix. So matrix A is a 2 by 3 matrix, and matrix B is a 3 by 4 matrix. Then A times B would be a 2 by 4 matrix, but B times A would not be possible, since matrix B's columns are not equal to matrix A's rows, a number of rows. So this justifies why it could be never, but to show that sometimes, we have to also show that it could be true. So let's just say we had a square matrix. So suppose we have a square matrix. Matrix A is a 2 by 2, and matrix B is the identity matrix. And then here's an example. Let's just say that A equals this matrix. So let's just say that matrix A equal the matrix 1, 2, 3, 4. And matrix B is the identity matrix. From that, we'll go ahead and evaluate A times B and B times A. If you need to, you can use the Desmos calculator to calculate A times B and B times A. But for both of them, you should get 1, 2, 3, 4 right here. So because of that, since they're the same thing, it's possible for A times B to equal B times A. But since it's sometimes and not always, matrices are not commutative. So since that's not the case, since it's not always true, since they're not always equal, we can say that matrices are not commutative. And this would be our two examples. This is when it's true, and then this is when it's false case. So it's sometimes. Looks like you've made it through the whole video. If you need to, watch some parts of the previous videos if you need to, and good luck on your test.